Howdy folks, yep, you've read the title right. I will be taking this Radeon 6650 XT and I will be connecting it to this Pentium 3 850 megahertz system, and I will be getting graphics output and using this. And also, I will also be using a slightly older GPU for software reasons, which I will go over later in the video. We'll actually be getting 3D acceleration out of this and hardware video decoding. So stay tuned for all of that. I'm going to do a bit of an explainer about what you see here and how this is possible, given that this system was built before PCI Express was even invented. And so if you want to understand that, of course, just keep watching. I will put a timestamp here and in the description if you just want to skip to watching it work and you don't care about any of the technical details. So to start things off, I want to get a few things out of the way. I'm using this GPU because this is the most powerful modern GPU that I have. This would work just as well with like a 6950 XT, you know, if you want to go full top of the range. But again, that's just not what I have. This card is actually quite new to me. And you could also use an NVIDIA card. The reason why I'm using an AMD card is because of drivers with Linux specifically, because we're going to be using Linux to do this. And of course, the AMD GPU driver is in tree in Linux kernel. The NVIDIA driver is not. And because of that, it makes getting the NVIDIA driver, at least the proprietary one, essentially sort of non-functional. It's kind of a showstopper. So while you could get it to work a little bit, your functionality would be reduced. So that's the reason why I'm going with an AMD card. The next thing is this motherboard, because you probably have a variety of questions about that. And so I'll go on a little aside as to what this is. This is your standard Pentium 3 850 megahertz. I think it's a socket 377, and it's got 512 megabytes of SD-RAM. This is before DDR. This is just regular SD-RAM. This is the maximum that this system supports. It has an Intel i8-15 chipset, which has a bunch of stuff built into it. So we have 10100 networking. We have PS2, all that kind of good stuff. There's onboard audio, and there is also onboard graphics, but the onboard graphics are kind of broken, at least the analog output. It's all smeary and looks terrible, so it's disabled. But that's basically what the system has on it. Now you might be wondering, this is not a normal motherboard, and this is not an ATX board. This is a sort of an odd form factor that Intel came up with in the 90s called NLX. And the idea behind NLX is that rather than your expansion cards coming out the side of the board at right angles, the actual motherboard itself is an expansion card, and it uses this very strange connector which supplies both the board with power and also provides all of its expansion, as well as a floppy channel and a PATA channel and a couple other things. And so in order for this to work, you need a backplane. And so I have a backplane here, and this is what a standard NLX backplane looks like. And so you've got, of course, your large connector here, which is the edge connector on the motherboard, and then we have the expansion slots. And then we've also got things like PATA and floppy and power input. This uses the older 20-pin power connector. And the reasoning why this was developed is so that the motherboard could actually be essentially a card, such that if you want to take the motherboard out of your system, with ATX you got to take all your expansion cards out and to get the motherboard out. Whereas with this, you can leave all your other expansion cards in place and just take out the motherboard for servicing. And the other thing that you may have noticed on some of these boards is who makes this. This motherboard specifically. I like to call it the Pele 2, not sure if that's exactly what they were going for, but this is made by NCR. Yes, that NCR, National Cash Register. This is an ATM motherboard, and they seemed to like this form factor for some sort of probably mechanical reason. But anyway, this is out of an ATM. I had to buy this separately, but I came across this at a thrift store, and I honestly actually bought it just for the heatsink that it came with, because that was... I did that for another system, and turns out that I I bought this on eBay just to get the system running, and it works. It's a little bit odd. It's got some dip switches and other stuff that's ATM related. It's got some firmware on it that is obviously for ATM use. No idea how to use it. No idea what it does or anything like that. But it functions like a normal board. Other than that, I just wanted to explain the what you're looking at is strange, but I want to make it very clear that this will work with any system like this. The fact that it's an NLX, ATM motherboard has nothing to do with what I'm trying to do by putting a modern GPU on this system. I just want to dispel, what you're seeing here, just so you can sort of understand what's going on. But this system is from 2002, and PCI Express was not was not released till 2003. So this system, the Pentium 3, would never support PCI Express. And so the expansion options that we have are ISA, right, the industry standard architecture. This is essentially the original IBM PC interconnect, which is either 8 or 16 bits, 16 bits in this case, which is a fully manually configured bus. It's just a direct data bus. So you have to set up all the interrupts and addresses and everything manually. And then in the mid-90s, we had PCI, which was 32-bit, 33 megahertz shared bus, so a lot faster, and it also offered this amazing new thing called plug and play, where the devices would work together with the platform to automatically configure their addresses and IRQs and detect conflicts and other things like that. And so, of course, PCI Express is different still, but this is the newest expansion that we have on this platform. Now, you may have seen probably around the time when PCI went out of style, you may have seen motherboards that actually had both PCI Express and PCI slots. And even though the actual the platform, like the CPU and the chipset, didn't have any PCI capabilities, because PCI is not part of the IBM PC spec. ISA is. So even your brand new AMD 7000 series Intel Rocket Lake CPU has an ISA bus. Even though it's not connected to anything likely, it exists. It must exist. In order for a computer to be a PC, it must have an ISA bus. But PCI is not in the spec. So they dropped that in favor of PCI Express as fast as they could. But in order to get those kinds of boards, there is a technology that was developed by the PCI Special Interest Group. I think it's the PCI SIG. They're basically the body that oversees the standardization of PCI and PCI Express. They defined a standard for bridging PCI Express to PCI. So if you had a new system that you needed to put PCI devices on, which is something that's very common in industry, you could basically get some sort of chip that would create a PCI bus and connect it to a PCI Express interface. And so those motherboards that had the combination of slots, they have one of those chips on board. In fact, actually, let me see if I can go find one of those. So here's an old board that I have, and this has both PCI Express and PCI slots. And as far as I know, this chipset does not have PCI support, and so somewhere I think it might be under the heatsink because they probably put the chip near the chipset. There is a bridge chip which creates a PCI bus and hangs it off PCI Express, which is what's natively supported by the platform. And PCI Express, as part of the standard, it supports these chips and running PCI buses through PCI Express. And it's actually common, especially on sort of low volume or more industrial products, to even brand new to buy things like CAN bus cards or serial port cards or whatever that are PCI Express cards, but they actually are like the actual chip that does whatever communication standard you want is really low speed. It's an old chip and it's a PCI bus chip. And so rather than designing a whole new ASIC, it's very expensive. So instead they just put down a bridge chip, and that's what makes it a PCI Express card. So it's actually a PCI device on a PCI Express card. And I don't happen to have any of those, but when you actually look, if you do LSPCI on Linux, you can usually detect those devices. You can actually see where those bridges are. But this is all, great information, but this is for the opposite situation. This is where when we have an old PCI device, we want to plug it into a PCI Express slot. What about the opposite case, which is what we're dealing with on this old board? Well, this is one of the lesser known kind of cool things about PCI Express, is that when PCI Express was developed, they wrote into the specification that PCI to PCI Express bridges would be bidirectional. So it means that you can run those bridges in reverse, and you can actually connect a PCI Express device to a PCI bus through essentially the same bridge chip. And the only way that this is possible, because of course PCI was designed before PCI Express, and so it has no knowledge of PCI Express. So they actually designed things into PCI Express to allow it to be backwards compatible. So essentially, for something to be fully PCI Express compliant, it must support operating through one of these bridges. And I happen to have one of these bridges right here. And so this is pretty much the magic device that is going to make this all work. Now this bridge happens to be made by PLX, which is a very common manufacturer. A lot of people just call these PLX bridges because this company is so synonymous with these chips, but they're not the only company that makes them. And this is a simple riser. You can see it's just a regular 32-bit PCI slot, and then we have an X16 PCI Express slot. Now, obviously, it's not electrically X16. It's actually electrically only X1, but it's got a full slot here just for mechanical rigidity. So on this side, we really don't have anything special, basically just an oscillator, some sort of management and power supply, and then on the other side, we just have the bridge chip, and that's it. And so even though this board, was designed before PCI Express, it's the PCI Express side which has the backwards compatibility to work through PCI. Now, there's obviously going to be some limitations of this. The first one being the bandwidth, obviously, of PCI is significantly slower, and of course, it is a shared bus with all the slots. So all the slots share the bandwidth, whereas with PCI Express, it's usually dedicated. And the other thing is interrupts don't work nearly the same way as they do on PCI and PCI Express. So it interrupts, things like MSI-X interrupts and stuff don't work. And so the device is going to have to downgrade what types of interrupts it can use. And depending on how the driver was written, it may or may not work properly at all. So from an electrical perspective, it works, but from a software perspective, it's up to the driver. It just so happens that there are some issues with the AMD GPU driver, specifically with this card, but enough of it works that you don't really notice. Whereas with the more modern card, I had some problems on some later kernel versions, which is the reason why I'm using the other card to showcase some of the features. I just didn't want to have to deal with building custom kernels to try and get things working. I just don't have the time to invest in that. So yeah, this is you can buy these there if you really want to play around with this kind of stuff. So technically, I could use an older system. I have a 133 megahertz 586. So that's an original Pentium, and I could also use it in that situation. Everything would work the same. It's just that it would require a lot more effort, and of course, everything on that system is way slower, and I just don't have the time to dedicate to it right now. So you just have to suffice with this. So I am going to assemble this, put this together, and put in the 6650 XT, and we'll power it up, and I will show you it working. Here is the setup on the floor, as always, just like all other temporary things here. So we have our motherboard, riser card, our PCI Express bridge, and then our GPU. This is an AMD Radeon 6650 XT. This is the highest end card that I currently have access to. So of course this could be like a 6950 XT. I just don't have that. It's just sitting on a little battery charger and a floppy disk just to keep it propped up. But the rest of this is just a pretty bog standard system. Just got an old PATA hard disk, floppy drive, CD-ROM drive, that old OCC power supply that still works for some reason. I've got a CRT here for video output. And then I've just got keyboard and mouse and things like that. I'm using an HDMI to VGA adapter, just because, of course, there's no analog outputs anymore. And I thought the CRT would be nice. It's just kind of a nice vintage look. This system has, of course, PS2 mouse and keyboard. I've also got networking on here. And there is another video connector here. This is for the built-in Intel i815 graphics. Now this isn't used, this is just going to a monitor that's not even plugged into power. The weird firmware on this motherboard, because of course it's an ATM, it requires something to be plugged in here so that it can get an EDID. It will not post without this, but once it posts, I can even unplug this and it will make a difference. So to prove to you, obviously this is coming out through here, going through the cable that's attached to the actual CRT, and it goes back off there. So we are actually driving out of this, and there's no power button on this. So I'll just turn the power supply on, and we can watch it boot up. And as you can see, we have video here, and there it is. It is a Pentium 3, 850 megahertz. The system is fully loaded with 512 megabytes of RAM, and of course it is going to do a full memory test on that. So that takes a hot second, and I don't know if I can really show this any better. The card is quite large compared to the motherboard size here. And anyway, this is the built-in firmware that's in ROM on this board, and I don't really know what it does or how to interact with it at this point. And that's not really all that important. Now, as far as the kernel goes, I'm using kernel 5.10, and that's because that's the easiest for me to use. Basically, I didn't really want to dedicate a whole lot of time to this project, so I basically just went with an off-the-shelf kernel, because of course you have to compile it specifically for for a 686, and the issue with that is that we won't be able to get the full capabilities out of this card, and that's because, unfortunately, the support for the AMD Radeon 6000 series came out in Linux 5.11, and of course this being 5.10, it doesn't fully support this card. So we will have video output, but it will not be 3D accelerated. And that's why I've got this other card here. So once I show you that this is working, and I'll show you what it can do, I'll put this older card in it. This is some old fanless card that I had. This is get it the right way around. This is a HD 6450. So this card does have full support in 510, and this will have full 3D acceleration, and we can actually play back full 1080p video with hardware decoding and all that stuff on this card, which we can't do on this right now. I could get a newer kernel. The latest kernels don't work because they've added in assembly instructions that this processor doesn't support, so they won't boot. And 5.15 panics. So there's some issues with interrupts, which doesn't surprise me because of the way that interrupts work over the bridge. So anyway, yeah, if someone else wants to spend the time and tweak a kernel to make it work, I'm certain that you could get proper decoding and everything on this. You just have to add the firmware on the system so that it can load it into the card and all that stuff. But unfortunately, I just don't really have the time to do that. So, beauty of CRTs, you can see me. So of course it's a Pentium 3, so it's going to take a hot minute to finish booting all of the graphical elements. And there's a login screen, so I will log in. And we do actually have disk activity. It's on the riser, interestingly enough, because that's where the PATA interface connects. So if I try and put the camera in my other hand here, I've got a ball mouse, so I have to put it on my thigh here. But this installation is using XFCE. I just thought that made the most sense. And here we go. and there we go. So that is essentially fully booted. And so this is unfortunately software rendering, and you can kind of tell, if you move a window around, you can clearly tell this is all just done in software, unfortunately. But I can prove just with LSPCI here what hardware is in here, and you can see we have the bridge. So we have our PCI Express bridge, which in this case is of course made by PLX. And then you can see we have our Navi 10 GPU connected to that, and then we've got the video and audio devices of that. And really, there's no more that we can do because there's no firmware loaded onto this card. The fans are not spinning down. The card's actually quite warm because it's essentially just running in sort of like basic compatibility mode because the AMD GPU, like I said, doesn't support this card. So unfortunately, there's really not much I can do. I can't play video files or anything like that because it's all going to get done by the CPU, and it's going to be horrendously slow. So what I'm going to do right now is I'm going to shut it down, and I'm going to swap this card for that card, and that will be more of a true-to-life showing of what this could be like if I spend a bit more time on it. So let me swap that around and boot it up. I'll save you that whole process. So here we are, just loading up. And so graphics acceleration is working. And I will show you the output of LSPCI on this as well. So you can see now when I move the window around, it's much faster, much smoother. And we'll just take a look at the hardware here, and again we have the same bridge, but now you can see we have the Radeon HD 6450 listed right here, and of course the HDMI audio device. So that's all working. Now to show off the video decode, I unfortunately I can't really stream a video to this because the actual overhead of basically downloading information over the network and then trying to do everything else is a little bit too much for it. You can see just the system just idling maybe I don't know, somewhere between 5 to 10% at about 200 megs of memory or so. So anyway, what I've done is I just went to the YouTube homepage and I just downloaded just a random video that was HD. And so I'll only show you a couple seconds of it for copyright reasons. But what I'm going to do is I'm just going to use MPV, and I'm going to set the hardware decoder and video output to be GPU so that it will use the actual Radeon card. And if all goes well, we should get smooth playback once everything initially loads. So it's going to use VA API, and so now you can see we have smooth video. Let's see if we can get to something that's got motion in it. But unfortunately, why is everything so still? But hopefully you can see that this is relatively smooth, and even the overlay is a little bit too much for it. But this is 25 frames per second, and essentially once it doesn't have to do any overlay, it is perfectly smooth, no frame drops, which for an 850 megahertz Pentium 3 is just a little bit exciting. So yeah, so you can indeed use a modern GPU on an old system like this, and I have another system that is even older. It's a 133 megahertz 586, so it's a Pentium. And technically speaking, I could do the same thing with it. I'm not going to, I don't have any plans to, just because I'd have to get all of the graphics stack and all of the kernel and the firmware, and I have to get everything set up to do this, and I'm not interested in spending that kind of time to just essentially show you essentially the same thing as this, except it'll be just less capable just because the CPU won't even be able to run like the regular application fast enough to even feed the GPU. So it's going to just be, I can prove that there's video output, but I don't really think that's all that exciting. You can imagine what that looks like. You just kind of have to trust me that it would work if I had done it. So yeah, that's this. So I don't know. Is this the oldest mashup of modern GPU and old PC? Has someone done something older? I'm not sure, but this is definitely older than the Socket 775 stuff I see all the time. So I thought this would just be kind of cool to share and sort of to explain how these PLX bridge chips work and how sort of forward thinking they were when they designed the PCI Express specification to allow for this backwards compatibility. I just thought it was quite neat. So anyway, thanks for watching.